Lastly, testing continuity. When we test continuity of piecewise functions, really it's fairly straightforward. We just have to test where where there's potential discontinuity. These three are all continuous functions, so we don't need to test any points in between. We just need to test where they transition. So we need to test at x equals -5 for continuity. We also need to test at x equals, looks like x equals 3 for continuity. Okay, so when x is greater than 3, we're going to use this. X is between -5 and 3, we use this. X equals 5, -5, unless we use the top function. So we test, and we can do this formally with a limit. So we can say that the limit as x approaches -5 and from the negative side, okay, what is the value of f of x? Okay, from the negative side, at x equals -5, f of x is equal to 0. Then we can check what's the limit as x approaches -5 from the positive side. Okay, well, this is still green. Okay, from the positive side, we're going to use this function here. So of f of x, we're going to use the square root function to establish a coordinate, and we end up with plugging in -5, we get 0. Okay, so there's another point here. So in this case, we can say that the left-hand limit and right-hand limit is defined at -5, so this is continuous at x equals -5. So then we could test x equals 3. So then we test the limit as x goes to +3 from the negative side. From the negative side, we're going to plug in 3 into there. So we end up with square root 25 minus 3 squared, which is 9. So it looks like we're calculating, I'm looking at 16 square root or 4. I test it from the right-hand side now. I test it in the other equation. So when I plug in the 3 into this equation, I get 3 minus 5 squared. Okay, so that's going to be 3 minus 5 is -2 squared is +4. Minus 1 is equal to 3. So because these are not equivalent, we can say that it must be discontinuous. At x equals +3. Okay, so this one passes both tests. The left and right hand limits are equal, and the point is defined at x equals -5. Here, this just doesn't pass the first test of continuity, in that the left and right hand limits do not equate. So that cannot be continuous because of that.